Alright, today we're going to step it up on you a little bit. We're going to actually start solving equations with variables on both sides. So what this means is, traditionally up to this point, every time you've been solving an equation, you've only had one variable and it's only been on one side of the equation. Now what's going to happen, it's still just going to be one variable. There's just going to be x or y or m that we're solving for, but now it's actually going to be on both sides of the equation. So just to give you a picture, it's going to look something like this. Instead of just saying 5x plus 8 equals 13 or something like that we're going to solve, now you're also going to have some variables over here on the other side as well. So it's going to kind of add one more step to our solving process, but nice thing is most of your background knowledge is still going to take care of you here. The question in your notes says if our goal is to isolate the variable on one side of the equation, which it still is, and I have students sometimes think, well, okay, we're going to try to get it by itself on both sides. The idea is still to isolate the variable on one side of the equation. So if we have variables on both sides of the equation, what do we need to do? And what I have here is to help you think back, what do variables represent? If I have an x or a y or an a or a b, what do they actually stand for in those equations? And the big thing to remember is they stand for numbers. They still stand for numbers. So in the past, we've had an equation like 2x plus 5 equals 11, let's say, and we tried to get x by itself, and we wanted to get rid of this plus 5. And how would we do that? Well, we'd subtract 5. And now that plus 5 is no longer on that side of the equation. We're going to do the same thing then with variables. We're going to try to get them off of one side. We're trying to get rid of them, and we're going to use a lot of the same steps that we've done before. So the idea to solve equations with variables on both sides, and this is the number one key. The big thing is you're going to use addition or subtraction to move all the variables to one side of the equation. And notice move is in quotations. I'm not exactly saying we're moving variables, but we're definitely getting rid of variables on one side. So if we see variables on both sides, if we see a problem like back here in the title side, 5x plus 8 equals 13 plus 2x, we're going to use addition or subtraction to get those variables on one side of the equation instead of having them on both. And the big thing that it says in your notes, and I want to make sure you understand this, if you have variables on both sides, other than combining like terms or simplifying like we talked about earlier this week, this would be the thing that we have to do first. Once you've simplified, the next big thing is you want to make sure you have all your variables on one side of the equation. Now, the same rules are still going to apply. What that means is we're going to use an inverse operation. If I see a positive, I'm going to subtract. If I see a subtraction, I'm going to use addition. You're going to use the opposite of what you see to get rid of the variables on one side. And remember, whatever you do to one side, you must do to the other. And that's how you're going to actually end up getting them on one side. If you subtract by 2x on the right, you're going to subtract by 2x on the left. If you add 3x on the left, you're going to add 3x on the right. Whatever you do to one side, you must do to the other. And then once your variables are on one side, basically using combining like terms at that point, then you're going to have just a regular two-step equation like we're used to, and you can solve it normally. So let's get into the examples and see if this can make some sense. It says 5n minus 2 equals 3 times n plus 2. So again, from earlier this week we talked, you might have to simplify before you solve. So I notice I have some distributive property stuff going on here. The left side of my equation is not going to change. It says 5n minus 2 now equals whatever 3 times n and 3 times 2 is. 3 times n is 3n. And 3 times 2 is 6. I just distributed the 3 to the parentheses. And now we're in the situation that we've talked about. We have variables on both sides. We've got to get them on one side. So I asked myself, okay, well, how am I going to do that? And really, the nice thing about algebra still, remember, you have options. You can look at the 5n and say, okay, I want to get rid of 5n over here. Or you can look at the 3n and say, okay, I want to get rid of the 3n here now. So if I want to get rid of this 3n, I just ask myself, okay, if it's a positive 3n, and that's just some number, 3 times some number, if I wanted to get rid of 3n with this positive here, all I have to do is subtract it. I'm just going to subtract it. I'm going to take it away. Remember, we're only using addition or subtraction to do this. Multiplication and division won't actually help you get rid of variables. But we're going to subtract by 3n on the right. But remember, whatever I do to one side of the equation, I have to do to the other. So I'm going to go over here by the 5n, and I'm also going to have to subtract 3n. The goal is to keep that equation balanced or keep that scale balanced. But what happens here by doing this, notice 3n take away 3n, that's 0. This stuff goes away. I'm just left with 6 on the right side now. The key to doing this right then is since I subtracted 3n on the right, I have to do it on the left as well. And I say, well, 5n take away 3n, that's 2n. So I have 2n minus 2. Remember, that's just combining like terms. If I had 5 apples and I took 3 apples away, I'd still have 2 apples. And now look at this. Now you're back to a regular two-step equation like you should know how to solve at this point. You cover up the 2n, you add 2 to both sides, you have 2n equals 8. And then your last step to get n by itself, you divide by 2 on both sides, and you get an answer of n equals 4. Remember what we've talked about all the time. You can actually check these by using substitution. I'm going to substitute this back into the original equation. I'm going to say, okay, if n equals 4, then that means 5 times 4 minus 2 has to equal 3 times 4 plus 2 in parentheses. And look at this. Well, 5 times 4 is 20. Take away 2. That gives me 18 on that side. Over here I have 3 times 4 plus 2, that's 3 times 6. Hey, that's 18, and hey, it worked out. So and does equal 4. So again, that's the basic idea. Use addition or subtraction, move all the variables to one side using an inverse operation, and then whatever you do to one side, you must do to the other. So let's look at another example, and notice it says in your notes some good math and life advice is to stay positive. On this equation, it says 8y plus 4 equals 11y minus 17. We've got to get the variables on one side. So some people have the habit of coming here and saying, okay, well, I'll subtract 11y on both sides. And this is totally fine. We could absolutely do it this way. But notice 8 take away 11 ends up giving me a negative 3y. It kind of gets a little messy from there, and you have to keep track of positives and negatives. What I would encourage you to look to do is actually subtract the smaller term with the variable if possible, meaning I'm going to subtract 8y on both sides. Even though I know that's going to give me the variable on the right, I think it's easier to solve this way. 8y minus 8y is 0, so that stuff cancels out. I'm left with 4 equals whatever 11y minus 8y. Again, combining like terms. 11 take away 8 is 3, but it's 3y minus 17. And again, now you're back to a two-step equation that you should know how to solve. Hopefully we know to add 17 on both sides. That gives us 21 equals 3y. And then y is not by itself because they're multiplying by 3, so of course I have to divide by 3. Divide by 3 on both sides, and y equals 7. So again, addition or subtraction, do it to both sides, and then just remember you're actually combining like terms. This one obviously had star. This is still tricky for you guys to deal with these fractions, but it does say use your background knowledge. Remember the idea to get rid of fractions. We're going to multiply everything by the least common denominator. Multiply everything by the least common denominator. So in this case, I have 5 and 10. If I was adding 1/5 plus 3/10, what would the common denominator be that I have to get it to? Well, I'd have to change this to tens. This would be 2/10. And that's how I would work that problem. So the least common denominator is 10. I'm going to multiply everything by 10. And guys, I mean everything by 10. So you really got to be careful when you're showing your work here. But I have 10 times a divided by 5 plus 10 times, notice this is a negative 3/10, which equals 10 times a over 10, and then plus 10 times 2. So everything's being multiplied by 10. We work through this the way we go. Remember, divide by the bottom, multiply by the top. So I have 10 divided by 5, which is 2. 10 divided by 5 is 2. 2 times a is 2a. So that takes care of that term. We go over here. I have 10 and 10, one on top, one on bottom. They are going to cancel out. 10 divided by 10 is 1. 1 times a negative 3 gives me negative 3 on that one. Really keep track of your signs on that is the key. Again, you see here where we're going to have some 10s that cancel out, and you're just going to be left with a, and then you have plus 20 over here on that side. Multiplied everything by the least common denominator, multiplied everything by 10, and then simplified. From here, before I do anything else, remember what we said, we're going to do this first. We're going to get the variables on one side of the equation. So I look here, and again, I could subtract 2a or I could subtract a, but the goal is to stay positive if possible. So I subtract a on both sides. This is where, for some reason, I always have kids make a mistake. They tell me 2a minus a is 2. Remember, the coefficient here is understood to be 1. This is 2 apples minus 1 apple. That still leaves us with an apple here. That leaves us with a. So I have a minus 3 equals 20 because my a is canceled out over here. And then the nice thing about this is really just a one-step equation. You add 3 to both sides, and you find out that a has to equal 23. So that's just the basics of getting the variables on one side of the equation. There is one other big important topic that's in our notes here, but I do want to make sure we understand this idea. We can use subtraction, we can use addition, but we have to move all those variables to one side using an inverse operation and doing the same things to both sides. So let's look at these next examples and see what happens here. A really important topic that we're going to talk about in notes right now, something you're going to want to remember for the rest of this unit and this year really. Going to clean this equation up. I want to use the distributive property. I have 5 times 2x and 5 times 1. 5 times 2x is 10x. 5 times 1 is 5, so I have 10x equals 10x plus 5 equals 10x. And then notice I want you to get the variables on one side. So okay, I'm going to subtract 10x on this side. I'm going to subtract 10x on this side, and this is where it gets really weird, so I hope we're paying attention. But if I have 10x and I take 10x away, I got nothing. They're going to cancel out on both sides, actually. All I'm going to be left with is this 5 equals, and then I don't have anything over here, so math, if I don't have anything, I put a 0. So that equation, when we work it out, our variables cancel out, and we're left with 5 equals 0. Not going to go into that answer just yet, but I want you to think about what that means. It's kind of funky. 5 equals 0. Let's try 5 as well together. We have 6x plus 2, and then I got to do some distributive property. 2 times 3x is 6x. 2 times 1 is 2. So this one's unique. It says 6x plus 2 equals 6x plus 2. Still got to keep going. Got to get the variables on one side, but hopefully we're starting to see something that might happen. Notice when I subtract 6x on both sides, they both cancel out. But in this case, I'm left with 2 equals 2. So when I notice about these equations, they both have variables cancel out. One of them ends up being 5 equals 0, which I think we all agree 5 does not equal 0. That's kind of weird. 5 isn't the same thing as 0. On the bottom equation here, we have variables cancel out, and we're left with 2 equals 2, which I think is very much a true statement, that 2 does equal 2. What this comes down to, I want you to go back to this basic idea right here and right here. I want you to look at these equations. The one equation was 10x plus 5 equals 10x. The other equation was 6x plus 2 equals 6x plus 2. Remember, when we're solving equations, we're trying to find a value that we can put in for the variable that would make the sentence true or make the equation true. In this first one, this is telling me some number plus 5 is the same thing as that number. It wants to know what I could put in here where if I add 5 to it, it's the same thing as if I don't do anything to it. And that's where I want you to think about it. How would that be possible? If I had any number here, let's say I had 7. Is 7 plus 5 ever going to equal 7? Is 10 plus 5 ever going to equal 10? Is there any number that we can put in here for this variable that's going to make that equation true? And the situation is no, there's nothing that we could put in there to make that equation true, which we'll talk about in a second. Compare that to the second equation here. This is saying some number plus 2 equals that same number plus 2. So let's say I have 8 plus 2. Is that going to equal 8 plus 2? If I have 100 plus 2, is that still going to equal 100 plus 2? And I think you should notice at this point, because they're the same expression on both sides, there's anything that we could put in there that would make that equation true. So two very different situations here. One where there's no possible answer that we could put in to make it work, and one where there's anything that could make it work. And that's the big takeaway from this set of notes right here. It says when solving equations, if your variables cancel out. And I want you to remember this, because this is the only time that we're going to end up with this situation. We have to have the variables actually disappear. Using addition and subtraction, they canceled out, and I'm left with just constants. If you are left with an obviously false statement, that means that there is actually no solution to the equation. And one way we show that, actually, and we'll talk about this when I get back, we show it with this symbol right here. It means empty set. It looks like a 0 with a slash through it, but it actually means empty set. It means empty set, which means there's no numbers. There's no numbers that work. It's an empty set. There's no numbers that work. So if there's a false statement, it's no solution or it's an empty set. Conversely, it says if an obviously true statement comes out when you're solving these equations, if the variables cancel out and you're left with something like 2 equals 2, then that actually means that all real numbers are solutions to the equation. And that's actually what we'd put. If I was solving equation number 4 back here in notes, we see that an obviously false statement means no solution or empty set. So number 4, when I get to this right here, when I get to 5 equals 0, that's where I'm going to put my answer. I'm either going to say, I'm going to have to write out the words no solution, or I can use this symbol that means empty set. That would be the answer for that one. Down on the bottom here, when I got to the point where 2 equals 2 is my answer, then I'm actually going to say x equals all real numbers. And I do expect us to write that completely out. But that means anything could work for x in that situation. So keeping this in mind, what we just talked about in the notes, let's try 2 last examples here. It says x plus 5 equals x. This is as simple as it gets as far as me trying to show you this idea. But again, the first thing I have to do is get the variables on one side of the equation. So I use subtraction to do that. I subtract x on both sides, and I notice that these cancel out. I'm left with that situation again where 5 equals 0. If I get to a point where all my variables cancel out and I'm left with an obviously false statement, again, this means my answer is either no solution, and that's what I actually write out, no solution, or you can put the empty set. One or the other works for me, but you're going to tell me that's no solution. You look at this other example, and maybe you're seeing it at this point, y minus 2 equals y minus 2. Still expect you actually to solve this from here. So I'm going to subtract y on both sides, subtract y. Notice I'm left with negative 2 equals a negative 2. And I hope we all understand that negative 2 does equal negative 2. Anything would work in that equation, so y equals all real numbers. I could put any number in there, 5, negative 100, 1/4, doesn't matter what it is. If I put it in there, it would work. So, very important stuff coming at you as far as the no solution and all real numbers when the variables cancel out. I know this slide of notes got pretty messy, but I do want you to kind of get that idea of still trying to get the variables on one side and then working it out. Really hard example with fractions that you could probably go over and look at again. Just multiplying everything by the least common denominator. And then just the basic idea of trying to get the variables on one side of the equation, either using addition or subtraction. Might have to simplify or use the distributive property first, but then the main idea is to get those variables on one side of the equation so you can isolate the variable and get your answer. Now we should be done with notes, should be ready to work on the assignment. Good luck.